Hi, and welcome back. I'm Hank Preston, a developer evangelist with Cisco DevNet, and today I want to talk to you about Python Part 3, Useful Python Libraries for Network Engineers. This is one of the lessons in the Network Programmability Basics video course, and we are at the tail end of our Programming Fundamentals module. We've already gone through lots of content. This is the third of the 3 Python modules, and after we also covered the APIs and the data formats lesson. So if you haven't caught those, make sure you do. If you want to follow along with the examples as we dive into some of these libraries, I encourage you to do that. Jump up to github.com/Cisco DevNet and download the netprog_basics GitHub repo. Inside, you will find readmes for each of the lessons and labs that detail how to set up your environment for all of the prerequisites and information necessary, as well as any access to information for the DevNet sandboxes necessary for the demos that we're going to run through in here. So make sure to grab that content. Let's jump right in. The topics we're going to cover in this lesson include libraries to work with data. So at the first lesson in this module, we talked about the different data formats of XML, JSON, and YAML. And in this module, we'll look at how we can use those data formats inside of our Python scripts, as well as CSVs, which are a common source of information for network engineers with different types of information out there. We'll also look at different API libraries you may want to use inside your scripts to interact with REST APIs, netconf Yang data models that will work with device APIs, as well as CLI when you do have to revert back to that native interface for network infrastructure. So libraries to work with data. We've seen all of the different data library or the data formats that you might have to work with, and we've got libraries inside of Python to make it easy to work with all of them. For XML, we've got the XML to dict library, which is available through pip. We can pip install XML to dict and then import that in to work with XML data. JSON is an embedded core library to Python that makes working with JSON a breeze inside of Python. For YAML, we can install PyYAML with pip install and take advantage of it, and CSV is also included. Now, one thing to note about XML, there is a native XML library. There's actually several native XML capabilities to Python that if you need to do powerful manipulation of XML, those are worth looking at. But if you simply need to access your XML easily, read the data, access and use them like they're in dictionaries and lists, that you can't go wrong with XML to dict, which is what we're going to look at. Speaking of XML to dict, let's talk about treating XML like Python dictionaries. And so what we have to do with XML data inside Python is come up with an easy way to work with it. XML isn't as natively transferable into Python elements as we'll see with JSON and YAML, but XML to dict gives us the ability to take that XML data that we've got from the schema and turn it into a dictionary objects inside of Python. Now, technically, it is an ordered dictionary because we need to maintain order inside of the dictionary, but we can work with it just like any other dictionary object. We've got functions called parse and unparse to take an XML string, turn it into a dictionary, and then take one of those dictionary setup and turn it back into an XML string if you need to revert it back. Let's take a look at how this script works in this example that's here. So to get started with XML to dict, the first thing we must do is go ahead and import it. And we can see that here at the top of the screen. We're importing XML to dict. Now we're also taking advantage of pprint that we looked at in the last lesson about the different modules that we might want to take a look at. Now for this example, included in the code library is the same bit of data in all 3 of the formats. So for here, we're going to be using XML example.xml, and we're opening that using the Python file or the Python open method that lets us open up a file. And we can see we're going to read that in. This gives us the XML data, the actual string data from XML available to us, and we can see that I've printed that out on the screen. So that's the raw XML output. But at this point, as far as Python is concerned, it is just a string. Now to turn that into something that we want to take advantage of inside of our Python, we'll use the XML to dict parse method that's available there. So by using XML to dict.parse and then passing it in the XML example, the string information, that then gives us access to use that XML, to use all of the information from that XML in a dictionary format. So we can see here how we're going to go in and we're going to create a new variable for interface name, and we're going to reference interface as the first level dictionary object, and then it has another key called name. And I know that those are there by just simply looking up at the XML data. This first interface ties back to here, and then we will get the name information because it's tying back here, giving us the ability to grab the details that are out of there. If we wanted access to the other information from the XML output that was there, we would access it using the other keys, such as description. would give us access to everything that's available inside there. With that by gathering the interface name inside of the interface name variable, we can then print it out just using that variable that's there. Now, it's also important to convert from these types of data formats like XML, but sometimes you do need to revert back to the native data format. And XML to dict gives us the unparse capability to convert that content right back into XML for storing that back as a file. Now that we've taken a look at how the XML works, let's look at that same example, that same data format, but now or the same data information, but now we're going to use it in a format of JSON and how we can work with that in Python. And so here we can see we can go very easily to JSON and back again using the JSON library that's native and built into Python. And so JSON.loads would take JSON string data and convert that into dictionary objects and lists. And JSON.dumps would take a dictionary and list object and convert it back to JSON string data to go back and forth very easily. Let's look at the code example here at a little bit closer to see how that works. In this case, we're going to start by importing again the JSON library so we can take advantage of the content that's there. Now, included in the GitHub repository with all the rest of the code samples is the JSON example.json, which is again that gigabit Ethernet 2 information, but now represented in JSON format. By printing that out using pprint, we can see the native JSON information. Looks exactly like we'd expect from JSON data that's there. Now, JSON is super easy to work with the JSON library that's there. So here we can see we're going to leverage JSON.loads, and that will then convert it into dictionaries and list objects depending on what is actually being stored inside of that JSON object. Once again, I can grab the interface name out of the JSON from the former JSON using dictionary references. In this case, we're going to grab IETF interfaces interface, which was the format of the key that's up there. We can see that here. And then the name information will come from the key that's there as well, up here. That gives me the ability to now print out the interface name using just the variable that's there and get access directly to the data that I'm after. When I'm done, if I've made my manipulations, I want to store this data in a format that's easy to work with, I can use JSON.dumps to revert this back to JSON format and then output that and write it to a string or send it to another API call that's out there. So with JSON under our belt, let's take a look at our next data format, which is YAML. And yep, Python can do that too. Almost as easily as we can do with JSON, with the biggest difference being we have to go ahead and use pip to install PyYAML, but once that's available, we can now easily convert YAML content using YAML.load and YAML.dump. They even sound like the JSON methods that we use there. Now, YAML objects will become dictionaries, the YAML lists will become lists. There's a from a functionality perspective, JSON and YAML are very, very similar when writing your Python code, and they're almost as close to be interchangeable. Let's look at this code example and how it works. All right, once again, we have to start out by importing in the library we're going to use. So we're importing in YAML. And then in the code directory, we've got YAML example, which gives us that same details about gigabit Ethernet 2, but now in a YAML format. By printing that out, we can actually see the raw YAML content with all of the new line characters and the indentation that YAML requires. With that available, now I can use YAML.load to load the YAML syntax into Python as objects that I can work with. Again, they're going to come in as dictionaries. And so here we've got our IETF interfaces that we've seen already in both XML and JSON. We're going to pull that out of the YAML format here. And then the name information is going to come from this line. Exactly like we saw with JSON, but now it's coming from a YAML data format. With that gathered into the interface name variable, now I can go ahead and just print that out. And once again, if I want to take the information, take the details that I manipulated inside of my Python script and convert that back to native YAML, the YAML library gives me YAML.dump, which will then convert it out. Now, displayed out in this format here, it's not as obvious with the white space indentation, but if we look at it closer, we can see the new line characters and we can see all the indentation that was maintained and done accurately so that we get a good YAML object coming back out of this. Now, our next data format we want to talk about is the CSV format, comma-separated values. Now, we can take any spreadsheet and we can convert an Excel spreadsheet or a numbers file off to a CSV file. And then now that it's comma-separated, that gives me something that I can programmatically work with and loop across different columns and rows that are inside of the data. Now, Python does include a CSV library that makes it very easy to read and write CSV objects here. So let's take a look at how it works. We'll start out once again by importing CSV, which gives us the ability to have access to all of those CSV tools. And in this case, the data format that's included in the example is a list of sites and routers and information. And we've got that in the CSV example.csv file. We'll go ahead and use the file open capabilities to read that in, and we can see the output of what that CSV file looks like here. And so it's three different elements. We've got the router 1, router 2, and router 3 located in New York, Denver, and Austin. Now, in order to use this effectively, it's a little bit different than we saw in some of the other ones. We'll open up our file name in this line, and then we use the CSV reader to go ahead and read in the CSV and process it appropriately. And what we end up with is a specific type of object that we can then loop over one row at a time that's in there. And so what we see here is we see our loop object for row in CSV Python. We're processing the details that are there. So the CSV, each element in the CSV is accessed using these the indexes as we go through. And so we can see row 0 is going to be imported in. And if we look back at our output, the first element inside of the row, that's this router 1, the name of the router. So we're going to go ahead and take that detail, and it gets put into the first block. The second element in our CSV, so we're skipping over, this shows that we can reorder the details that are there. That gives me the location is our second element here, in this case New York. And so the second element would show up inside of our details in this position. And then our last position for the IP address in our output, right, we're going to pull that directly out here from the first index, which is lists are in Python, and in most coding we're going to be indexed off of 0, which is why it goes 0, 1, 2. We're going to grab the first position there and then put it inside of the IP address. And that lets me print out the details here in a nice format of all of the routers that are available. Now, one of the things that's nice about the CSV object here is you can process, and you may have access to a CSV file with hundreds or thousands or tens of thousands of records. Now, if you wanted to import all of those at once and just use native file processing, Python would want to import all 1,000 or 10,000 of those records at once. The CSV library was actually built to efficiently work like that, to work around those large files without memory issues. So by using this, you can feel safe to process those very large CSV files and crunch and gain access to the data that you're after. Now, the CSV library does have special functions that let you support header rows and other formats, depending on whether that data came from Excel or some other format. So you can read the documentation and the help information on the CSV library to dive deeper to make sure you're formatting your CSVs appropriately. Now that we've looked at some of the libraries available inside of Python for working with data formats, let's talk about some libraries that are handy to have in our back pocket when we need to deal with APIs that are out there that we may want to work with. So the libraries we're going to talk about here kind of hit the key network programmability APIs you might work with. So we'll start out with requests, which gives us the ability to work with REST APIs that are out there. We can install that with pip install requests and then import it. And now we have an easy way to manipulate get, post, put, all the different methods we may want to work with. Now, inside of network configuration management today and network programmability, model-driven programming based on netconf is all the rage, and we're getting Yang data models supported by multiple vendors in open formats. NC Client is a Python library that lets you very easily manipulate and work with netconf sessions. It'll stand up the netconf session for you. It'll handle all of the RPC frameworks and those bits. Now, if you're not familiar with netconf, that's fine. Stick around in the next module where we dive into device-level APIs and spend a lot of time on Yang data models, netconf, as well as RESTconf. Our final API library we'll look at is NetMiko. Now, NetMiko is a community-developed library that's out there that kind of builds on top of Paramiko, which is an often used library inside of Python for dealing with SSH connections. What NetMiko does is it builds on and offers a very easy way to interface with both Cisco as well as non-Cisco and third-party network infrastructure to send command line syntax that's out there. And you can get started with it quickly with pip install NetMiko. We'll dive into each one of these and see how they work and see an example. The first one we'll look at is this request library that gives us the ability to have a full HTTP client baked into our Python code. Now, it's not the only way to do HTTP calls with Python. There are URL-lib and other libraries that are baked in. But what's nice about requests is it simplifies all of the authentication, headers, response tracking that you have to sometimes do that manually with other alternatives. So it's often seen as the only feasible HTTP client to be using in your Python scripts. It's great for all of the REST API calls, or if you just need to crawl a web page for some content, you can use it just to grab information like that. Let's dive in and look at how we can use requests to interface with REST-based APIs. All right, let's take a look at how we can use requests right directly within the Python interpreter. Now, of course, we could use requests, and you probably most often will use all of these API libraries inside of a script. But in this example, we'll run it directly inside of the Python interpreter to explore how this library works. So to get started, we need to import the library. So import requests. Now that it's imported, I have access to the features that are there. Now I'm going to also import pprint, prettyprint, so that I can take advantage of it in some of the output as we're looking at here. So from pprint, import pprint. Now with it set up, I need access to I want to provide the information about the device that we're going to connect to. And for this example, we're going to be using RESTconf as the REST API target that we're going to connect to. So I'm going to create a dictionary that represents the router that I'm going to use. So a little bit of general Python review here. So my dictionary of router, the first key that we'll use is the IP address of our router, and that'll be 10, oops, I need that, 10.10.20.21. The second key that we'll add will be the port. So port. So in this case, we're running our service on port 443. It's the HTTPS port, the standard one. Our username and password, so user, and that is root. And our password, which is Cisco123. That's the end of our dictionary, so we make sure that we don't include a comma at the end. We just put our curly brace to complete our dictionary definition. And now I have my router stored, so I can quickly and easily gain access to it. Now we are using a REST API, so we need to make sure that we provide the required headers. So we'll create another dictionary called headers, where we'll bake in all of the information that we need for our headers that we'll pass in. Now what we need to provide is we need to provide the accept parameter to indicate to our target router what type of data we want back. In this case, whether we want XML-based or JSON-based data. And so our header will be the accept, and then the value is application yang data plus JSON, and this indicates that we would like to get our data back in a JSON format. Now, as a REST API, we also need to know the URI that we'll connect to, so we'll say u equals, and we're going to use string formatting here to make this a bit simpler on us. So https:// and then we need to give it the host information that we're going to connect to. We'll use our string formatting here, so we'll just for now put in curly braces that will act as placeholders for the IP address and then also the port information that we'll pass in. The resource that we'll connect to and request is restconf/data/interfaces/interface equals gigabit Ethernet 1. As a reminder, in the following module, we'll go into all of the details on how to work with all of the different network device APIs, including this one of RESTconf. I've created a string that has the placeholders. Let's go ahead and update that string to have the actual data that we want. So I'm going to go ahead and say take the content of u, and I'm going to format it and pass in the information that I want to fill into those placeholders. So the first bit of information we need is the IP address. And we stored that in our router dictionary, so router and then IP. The second information we have to provide is the port. So back to our router dictionary, and we will use the port key in this case. We pass both of those into the format function. And now if I go ahead and we print u, we can see that we've updated our URL to include all of the information necessary for the complete REST request. And we're ready to go. So we're going to create our request object. We'll call that R, and we'll say that that equals requests.get. So the request library is a full HTTP client, so we're using the get method in this case. That would imply that there's also post, put, patch, and there is indeed all of those. Now what the get method needs is some information. What URL to get, so we'll represent that by u. The second bit of information are any headers that we want to add. So we'll say headers equal headers. We also need to give it authentication information. So how do we authenticate to this API? The request client makes this even easier for us when we're dealing with basic auth. So we can just say auth equals, and then we pass in the information on the username and password. Our username is router, is stored in the router dictionary as user. and the password is stored as in the router dictionary as pass. The last one we're going to provide, the last input parameter into the request.get is verify equals false. The reason we're doing this is the same reason we used the -k flag and we looked at the same API request in curl. This is running over HTTPS and SSL, and the certificate that's supported is a self-signed certificate. So we have to tell the request client to don't worry about verifying those certificates. Make sure it's okay because it doesn't have kind of a fully signed valid cert, which we've seen in all sorts of different use cases with lab infrastructure. Now with our request.get formatted appropriately, we'll go ahead and hit enter, and this will make that request for us. It'll take just a second. It's reaching out, going ahead to and connecting into that device. Oh, look at that. Python threw me an error, so let's take a look at what happened. So it's giving me some information here that the connection errored, was unable to make the new connection that was there. Now if I went back and looked, and in the magic of video editing I went and checked, and my VPN connection off to the DevNet sandbox had timed out in the process while we were going through some of the presentation. So I've gone ahead and I've reinstantiated, turned that VPN back up. So let's go ahead and take advantage of a real quick functionality inside of the idle interpreter to rerun that request. So I'm going to go ahead and place my cursor right here back with the call to open that GET request and hit enter. And what it does is it puts that same command right down back, and I can hit enter once more, and hopefully this time we'll go through. It was much faster as we've seen, and though I still have a warning, it's not the same bit. What this warning is exactly what you would expect based on that verify equals false. It's showing that there's an unverified HTTPS. So this is a warning. It says that there's definitely something they want us to be aware of because it's much better to use strong certificates, but our request was successful. We can see that by going ahead and saying pprint R, and in this case R represents our response object that came back, dot text to look at the actual output of the text of the data that came through. By looking at that, we can see that indeed there is the JSON data that represents our API call that went through. Now this is JSON data, so let's go ahead and see if we can process that like we saw with the other one, in the other example. So I'm going to import JSON, and with that available, I'm going to say API data equals r.json. The request library includes a function that will go ahead and convert that for me. So I can go ahead and say API data. Now I have a dictionary object, so I can go interface name equals API data. And then looking at what we had in our output, I can use IETF interfaces : interface. So what that would do is that accesses this top level, so I'm in the object, but what I want to see is the actual name of the interface, so we'll then pass in name as a second key for what we're after. With those in place, we grab our interface name, and then I can go ahead and just grab it out and say interface name, enter, and indeed we have access to our Gigabit Ethernet 1 interface that's there. Really quick and easy, and as we've seen, we've been able to use requests and navigate that JSON data that came back in a very programmatic fashion. All right, now that we've finished up with the REST APIs, let's look at netconf and dealing with Yang data models over netconf using NC client. Now netconf is that network configuration protocol. It's that new standard to update, to bring network configuration past the SNMP v3 days into a more stable, full-featured transport protocol for network programmability. NC client gives us a full netconf manager implementation in Python. Now again, we'll dive deeper into netconf itself in a later module and in a later lesson, but for now let's take a look at how we can use NC client and the value it offers us. It will also handle all of the details for netconf for you. So netconf is a great protocol, but you have to understand the XML, the authentication processes, how to set up and monitor your RPC calls. We'll deal with all of that inside of NC client automatically. And it provides you, as all netconf connections do, back in raw XML that you can then process appropriately. Let's take a look at how the NC client can be used live in this demo that's here. We'll take advantage of NC client, we'll connect to our devices, and we'll see what we can do with it. All right, now let's take a look at NC client in action to make our netconf connections. Now I'm starting this demo out with a clean Python interpreter again, so we'll start right from the beginning of how to use NC client. We'll start out with from NC client import manager. Now we'll talk more about NC client in the netconf module or the netconf lesson of the next module, but for now just understand that we're importing the manager capabilities from NC client as a library. Now once again we're going to take advantage of pprint in order to print out some data. So from pprint import pprint. And then the last one we'll import is our XML to dict library so that we can work with that XML data that's returned in an easy to use fashion. So import XML to dict. With those imported, now I need to set up my connection information. So just like we did in the requests example, we're going to create a dictionary called router that contains all of the information necessary for us to interface with our router device. So IP address equals 10.10.20.21. We've got port. Now in this case, we're interfacing using the netconf protocol, not the HTTP protocol. So the port is 830. 830 is the default netconf port as per the standard. Our user is once again root. And our password, just pass, is Cisco123. We'll end our dictionary about our router with a curly brace. All right, so the next bit of information we need to pass in is the netconf filter, which is the XML information that will tell netconf, the netconf agent on the device, what information we're interested in. Now, rather than type out all the XML and risk all these typos on the video, I'm going to take advantage of copy and paste just to put the detail in here. And so what we can see is I'm creating a string called netconf filter, and it goes through and starts out with filter, and it specifies the specific interface I'm interested in this case, Gigabit Ethernet 1. This is the exact same type of call we used in the request, but now we're using netconf instead of restconf. So I'll hit enter, and now I have my XML filter available and ready to go. The next bit of information we want to do is we want to create our netconf connection, and we'll create a connection to our router. We'll call it M, and we're going to use that manager object that we imported in from NC client. So manager.connect is the function that we're going to use to build this connection. And manager.connect needs a handful of parameters to know who and how to connect. It needs to know what host to connect to, so we'll grab that out of our router dictionary that's up there, and we'll say router IP. It needs to know the port to connect to, or connect on, so we'll say port equals router port. It needs to know the username and password, so username equals router user, and password equals router pass. And lastly, netconf needs to know, similar to what we saw in the request, we need a host key verify equals false. Now netconf, as we'll learn in the next module, runs over the SSH protocol. So just like when we SSH to a router that doesn't have a trusted certificate, we need to do, and we have to tell our client, we have to tell netconf that it's okay to skip the verification of the host key in that SSH protocol that goes through. With all of this information available and typed in, we can go ahead and execute our connect command, and this creates our connection. With that in place, now we can go ahead and execute the operation, the API operation we're interested in. So we'll do interface _netconf, and what we're going to issue is what's called a git config operation inside of netconf. So we'll do m.git_config. We need to know, we have to tell the netconf agent what are we trying to get config from. So in this case, we want to get it from the running configuration, and we want to pass in that filter that we created. So netconf_filter. With those provided, now I can hit enter, and this will execute that netconf command that we wanted. What this gives us back is that raw XML data. So let's use XML to dict to turn that into the information that we can use. So we'll say interface Python. We'll create a new version of this, and we will use XML to dict.parse, and we will parse interface netconf.xml. What we've got here is we're saying that when we made the git config connection in the previous line, that returns back an object that represents the returned details from netconf. There's a property in there called .xml that contains the XML output. So by using the XML to dict.parse, that now has given us a dictionary that contains all of the information that's there. Because it's a dictionary, we can treat it such, and we can go in and say, okay, inside of that dictionary, go to the RPC reply key, and then also go inside of the RPC reply to the data key. And again, we'll dive deeper into the netconf protocol and how all of this works in a follow-up lesson. But with that, that gives me access, RPC. Oh, I've got a typo. It's not RCP, it's RPC. So let's go ahead and fix that. So in here, so that first key shouldn't have been RCP, it should have been RPC. RPC. And with that, there we go, that was successful. So now that I've got my interface Python information, now I can print out that dictionary name. So to go ahead and do that, we'll go pprint and see how it works. We'll say pprint interface Python, which is the dictionary object that we created, Python. We want to go into interfaces, which is a list of the interfaces that are out there that were returned back. And we want a particular interface. We want an instance of the interface that's there, interface. We want to print out the name that's in there. Now the name inside of netconf is considered a key value, so there's some extra details that are there. We'll go through more of this later on, but for now, all you need to see is that if we go through and say we want to print out the text attribute that was returned, this should then show us back and give us the actual text name. Once again, Gigabit Ethernet 1. So one of the things we'll see in here is netconf as a transport protocol or as an API to go through, there are some bits of information we need to understand, and we'll cover all of that in a follow-up lesson in the next module. But we can see once we understand netconf, we can go ahead and manipulate that with Python in a very few amount of lines of code that are here. And our last client library for dealing with different APIs that are there will be NetMiko. Because sometimes CLI is truly the only option. You may have a piece of infrastructure that doesn't have an API available yet. Or maybe the infrastructure could support it, but you're not on a code version that has the API available, but you still need to get information out of it. In those cases, NetMiko is a great option. As I mentioned, it builds on the Paramiko library, which provides the underlying SSH connectivity, but it layers in knowledge about dealing with network infrastructure specifically to make it even easier to work with. A wide range of vendors and network devices and operating systems are supported, and it works, just like all CLI does, back in clear text. So if you do find yourself leveraging NetMiko, the post-processing of that data, reaching in, processing, using regex or other mechanisms to figure out what information of data you're after will be key to all of your uses of NetMiko. Let's dive in and see how this one works so we can connect and interface with using the CLI for Cisco IOS on our devices. All right, now that we've talked about NetMiko and how we can use it to interface with CLI as an API entry point into our infrastructure, let's see it in use. So to get started, let's go ahead and import it. So from NetMiko, import connect handler. So connect handler is the object that NetMiko provides that actually does the connection off to our infrastructure devices. And once again, we will use our handy dandy pprint library to print out some data. So from pprint, import pprint. Now our next bit is to set up our dictionary that represents our router object we're going to connect to. So router equals. The first one we want to use here is NetMiko leverages a concept of device type to indicate the vendor and the type of device that it's going to connect to under the hood. So we need a device type, and we'll set that to Cisco IOS. For the full documentation and range of device types supported, be sure to check out the official NetMiko documentation that's available via the link. With the device type set, the next bit we want is the host we're going to connect to. So we're going to connect to a host that's the same one we've been using, so 10.10.20.21. We need to provide the username and password to use. Root. With all of that detail set, we can go ahead and store all of our router information, and we can make our connection off to our device. We'll do that with net. We'll create an object called netConnect to represent our network connection, and we'll use connect handler that we imported from NetMiko, and we'll pass in the parameters necessary. So it needs to know what IP address it's going to connect to. We'll pull that out of our router dictionary, so router host. It needs to know the username, so username equals router user. It needs to know the password. And lastly, it needs to know the device type. So device type equals router, router, device type. With all of that information provided, we can go ahead and complete this and make our network connection off to our router. When we get it returned back, now we can take advantage of it. We can send some interface CLI commands off and process the results. So we'll say interface CLI equals net connect.send_command. What we're doing is we're sending a CLI command, and we just tell it what command we want to send. So we'll go and we'll say show run interface gig1 to keep the theme of looking at gigabit Ethernet 1 off of our device. I go ahead and send that, and I can now, once it's been sent and it comes back, I have access to the return data. So I can say we'll do pprint interface CLI, which stores the output of that send command. We print that out, and we can see that we indeed do have the output of the show run interface gig1 command. Now I can get access to the same detail that was available both through RESTconf with the requests API library, as well as through netconf with the NC client library. Same exact information, but I do not have an easy way to convert this text output into something that Python can work with. That again is the value of using good data formats, something that is very easy to code and work around. All right, let's sum up what we've seen so far. We've gone through a ton of information across this Python lesson. Now first, we looked at how we can use Python libraries to interface and manipulate all of the different data formats you may run across, whether it's XML, JSON, YAML, or even CSV data with different types of information that you want to store and process. We then ended with a discussion on 3 common APIs and how you can deal with them inside of Python scripts. We used requests to work with our REST APIs. We took advantage of NC client to work with netconf. And in the times when you just have to use CLI, we've got NetMiko in our back pocket to take advantage of there. Now coming out of this lesson, make sure you keep it going. Be sure to complete the full Network Programmability Basics course. This lesson does end the Programming Fundamentals module, but stick with me because we pick right back up and we dive into network device APIs and how we do model-driven programmability on top of the network in a modern fashion. If you didn't run the exercises as you watch the video, that's fine. Go ahead and run them now and keep your eyes open for bonus examples inside of the code repository. And if you haven't yet, take the time now to join us up on DevNet at developer.cisco.com. By signing in, you've got access to all of the learning labs and sandbox resources, not to mention a plethora of code samples and API guides for all of the infrastructure and equipment available. If you've got more questions as you're going through the program, or you've just got questions in general, you can find me up on GitHub at hpreston. I'm available on Twitter at hfpreston. And if you're still back in the old school days of email, you can find me at hapresto@cisco.com. I'm also available at Spark at that address. Be sure to follow Cisco DevNet on Twitter, Facebook, and all the social medias, as well as GitHub for all of the great code examples that we have. Thanks so much for sticking with me for this lesson. Hopefully you've enjoyed all of what you've seen so far, and you'll join us for the rest of the content in the Network Programmability Basics module, including Network Device APIs, our next module that comes up right after this.